block 2, make sure you answered the attendance question and checked the comments on the quiz that you should have handed in last week. You can do corrections for half credit back on separate files on the quiz correction posting that I posted. So you can do it on separate paper or your same quiz paper in a different color for half credit back. We spent a lot of the year so far just learning about or solidifying our understanding of linear functions and exponential functions. We're going to spend the rest of the school year that we have, about 2.5 weeks, on other types of functions. So we're going to move on to chapter 8 right now, which is all about polynomials. I put the definition of a polynomial in the post. Please go read that. Basically, it just looks like 3x squared plus 2, just like coefficients being multiplied with variables that are put to exponents. The exponents are never fractions, decimals, or negative, so we're just dealing with positive whole numbers. Polynomials can even be like just a number, like 3 or 3xy, but there were some examples on the post in the stream. So basically, they just look like normal expressions with variables and coefficients and exponents. We're going to be learning how to sketch them without a calculator. Now, granted, I can't control what you use at home, so if you want to check your graphs using Desmos or a graphing calculator that you have, that's perfectly fine. You're going to write down every single thing that I write and submit all this as credit for today. So I would suggest that if you don't have this printed out, if you don't have ink or you don't have paper, or you just would rather work on line paper, I would suggest working on graph paper just because we're going to be making sketches. So the definition of a rough sketch is you kind of have the general shape and maybe important points like the x-intercepts, but other y values that aren't part of the x-intercepts don't really matter. So we're just sketching for today. And again, if you want to check with Desmos, fine with me. You're going to get more practice on this tomorrow, but today is just notes. So let's just fill in, and again, pause, rewind, fast forward as much as you need. So when you sketch a polynomial, first you're going to plot the x-intercepts. Another word for x-intercept is a root or a zero, by factoring and using the zero product property. We did more of this in the beginning of the semester where we were factoring and using the zero product property. And then you kind of have two little subnotes here. So any double roots, and those are roots that are squared. So you're going to see them being put to the second power. Will cause a bounce. And this will all make more sense when we start doing examples in which the graph will not cross the x-axis. So let's say, for example, it doesn't cross, it kind of bounces off of it. So for example, if we have y equals x minus 2 squared, we're going to be seeing polynomials in factored form just because it's easier to get the x-intercepts. Because remember, when you're solving something with a variable that's like squared or cubed, or even to the first, you always like factor and zero product property to get your zeros. Remember, to find an x-intercept, you plug in 0 for y. So you have like 0 equals x minus 2 squared. You don't have to write this down if you don't want to, but so to find an x-intercept, we always plug in 0 for y, and now you would just zero product property. So x minus 2 equals 0, and then x equals 2. So that means you have one x-intercept at 2. So it has an x-intercept of 2, 0. That is a double root because it's squared, so it kind of shows up twice. Therefore, the graph will not surpass the x-axis at 2, 0. So in a similar way, any triple roots that are cubed kind of do something similar, except it's not a bounce. It's going to cause an S shape. So for example, if it was cubed instead, you would still have the x-intercept at 2, 0, because if you plug in 0 for y, it's already factored for you, and ZPP, you still get 2. It's a triple root because it's cubed, and the graph will have an S shape at 2, 0. So the reason why there's a bounce and an S shape is because anything that's squared always looks like a parabola when you graph it, and a bounce looks like a smiley face or a parabola. Anything that's cubed, like if you graph x cubed on Desmos, it looks like an S shape. So it makes sense that anything cubed makes an S shape. 2 more steps to these. The degree. I'm going to talk about how to find the degree of a polynomial, but basically you're just going to count the x's when it's in factored form. So the degree, or it's also the largest exponent when you FOIL it all out, but you can also count x's. Of the polynomial specifies how many times the graph will change direction, so like up, down, Squared counts as 2, cubed counts as 3. Again, this will make more sense when we do examples. And then lastly, an even degree has both ends pointing up. So even numbers point up. And you're going to see that these look like little waves all the time. So we can have both arrows pointing up for an even degree, and for an odd degree, we have the left end pointing down and the right end pointing up. So for odd, it looks like this. If your graph is flipped, meaning that there's a negative in the front of the equation, we've talked about these before, then you're just going to reverse these directions. So if we have a negative with an even degree, both are down. And if we have a negative in the front of the equation with an odd degree, then we're going to have left up and the right arrow pointing down. So let's do some examples of graphing polynomials, just sketching them without a calculator. We're just going to do this by hand. You'll notice these are some examples of polynomials. You kind of see them like actually foiled out more so of the time. So this is a polynomial. But it's always easier to graph them when they're factored because you can find their x-intercepts really quickly. So when we get to this example, we're going to end up having to factor. I'm probably going to have you do 1 or 2 on your own. So make sure you're doing all these examples and writing them down and uploading them to the posting for full credit. So it says fill in the information for the polynomial, then create a rough sketch without a calculator. So for number 1, we have x plus 3, x plus 5, x minus 4. So again, to find my x-intercepts, I can set everything equal to 0 and just ZPP. I'm not going to show the work for that because if I just set this equal to 0, I get -3, -5, and +4. So those are my 3 x-intercepts. It's basically the opposite sign of the number that's in there. So -3, 0, -5, 0, and +4, 0. Again, I set that equal. It's already factored. Set equal to 0. And ZPP, zero product property. Double roots mean, do you see a squared anywhere? So are any of these parentheses being squared? No. Are any of them being cubed for a triple root? No. So I'm not going to have any bounces or S shapes in this example. The number of changes in direction reflects the degree of the polynomial. So basically, I'm going to find this 2 ways. If you were to FOIL this all out, like first, outer, inner, last, and you would have to do it twice, just because you have to multiply these 2, and then whatever you get, you multiply with the x minus 4. What would be your highest exponent? Well, it's just the x times x times x that you're going to end up having to multiply is x cubed, and that exponent would be 3. Another way that you can find it when it's in factor form is you just count up all the x's. So there's 1, 2, 3. If an x is being squared, that counts as 2. If it's being cubed, it counts as 3. But in this case, we just all have x to the firsts. There's 3 of them. That means that we're going to have 3 changes in direction. And that also means, since this is an odd number, that the left arrow points down and the right arrow points up. So my first step is I'm going to plot my x-intercepts. So here's -3. Then I have -5. And I have +4. I'm going to start with my left arrow pointing down, and since I have no bounces or S shapes, I'm just going to go through all of them. And that's it. So go through, left arrow pointing down, right arrow pointing up. I'm going to count real quick that I have 3 changes in directions, up, down, up. Perfect. And that's the sketch that I am expecting. If you're not sure of your sketch, you can literally just type this into Desmos. It should look somewhat like this, albeit maybe this dips lower or higher, this dips lower or higher, but this is the general sketch. I have the shape, and I have the correct x-intercepts. Okay, let's try 2. So now I see a squared. So to find our x-intercepts, do the same thing. You set everything equal to 0 and ZPP. Make sure you do that for x's in the front as well. So if you set this x equal to 0, you just get 0. So one of the x-intercepts is 0, 0. This one, x minus 1 equals 0, would be 1, 0. And here I'm going to have a double root of -2, 0 because it's squared. So that's our double root. I'm going to put -2, 0. I have 1 double root. Nothing is being cubed. I don't have triple roots this time. Okay, so let's count our x's for the number of changes in direction. I have 1 here, I have another here, and this counts as 2 because it's squared. If you were to FOIL this out, it would be x squared. So 1, 2, 3, 4. 4 changes in direction, and that means both arrows are pointing up. Even degrees always have both arrows pointing up. So let's plot our x-intercepts. 0, 0, 1, 0, and -2, 0. I'm going to start with both arrows pointing up. And you just have to be careful with this one because now that you have a double root, you can't just go through it like you did these. You're going to bounce off of it. My double root is -2. That's the very first one that shows up. So I'm going to come down because my first arrow is pointing up, and I'm going to bounce off of -2. Arrow pointing up on the left, bounce off of -2. Remember, bounce means you're not crossing, surpassing. It just comes down and back up again, okay? And then my other ones are just the single roots, so I'm just going to go through them. Down, up. So this really looks like a lopsided W. Both arrows pointing up. I'm going down, up, down, up. That's 4 changes in direction, and I have my bounce on the -2. Again, plot on Desmos if you're not sure. Try number 3. So number 3 is not in factored form, which is the easiest form to be in to find your x-intercepts. I'm going to factor it myself. They all have an x in common, so I'm going to take that out. What's left over? X squared plus 11x plus 24. Just take an x out from everything. You can check your work. If you distribute, you should get the same thing, and I do. Okay? It's not factored all the way. So bring yourself to the beginning of the semester when we did these. What are 2 numbers that multiply to 24 and add to 11? That's 8 and 3. Make sure you keep your x in the front. If you're unsure about your factoring, you can literally distribute the x and then FOIL both of the parentheses, and you should get this again. But I know I factored correctly just because I was careful. So find your x-intercepts now. I'm just going to set this R of x. So you just set each part equal to 0, including the x in the front. Here I have 0, 0, -8, 0, and -3, 0. I don't have any double roots because in factored form, nothing is being squared. I don't have any triple roots because nothing was being cubed. How many x's do you see? 3. And this is a really good example of using the highest exponent when it's all FOILed out, like it would be x cubed because there's 3 x's. So 3 is the degree. Changes in the direction would be 3, and then that since that's odd, left arrow down, right arrow up. So I'm going to plot 0, 0. I'm going to have to count by something because I have to plot -8. I'm going to do 2's on the x-axis. So -2, 4, 6, 8, 2, 4. So actually that's -3, not +3. So -3 would be somewhere in between -2 and -4 right here. Okay, I'm going to start with the arrow pointing down. And I have no double or triple roots, so I'm literally just going to go through all of them. So this really looks like the first example, except the x-intercepts are a bit closer to each other. Okay, number 4, I see 2 double roots now because I see 2 things being squared. So again, ZPP, I have 3, 0 and -1, 0 as my x-intercepts. And I have 2 double roots. So that's 3, 0 and -1, 0. No triple roots, nothing's being cubed. Okay, how many x's do I see? Remember, squareds count as 2, so 2, 4. That means both arrows pointing up and 4 changes in direction. So let's plot 3 and -1. And I have both arrows pointing up. I'm going to bounce on both of them. So this is going to look like a W, bounce, that is sitting on the x-axis. If you have any questions, you can post in the comments below or on Google Classroom. I'm going to keep going. And we're going to see some cubes now. So again, same stuff, x-intercepts. I'm going to ZPP, set each part equal to 0. This is 3, 0, 4, 0, 5, 0. Opposite side of whatever is in there. I don't see anything being squared, but I do see something being cubed, which is a triple root. That's my 3, 0. Changes in direction would be, this counts as 3 because it's cubed. These count as 1 each, so that's 3, 4, 5. Since that's odd, again, I have left arrow down, right arrow up. Let's plot 3, 4, 5. Very close to each other. I'm going to start with my arrow pointing down. I'm going to come upwards. And I see that my triple root is the first one at 3, 0. So I'm literally going to draw an S shape. So it's not like a straight, not straight curve, but it's not like a normal curve, just like this. I see like a little bump with an S shape. And then the other 2 are neither double or triple, so I'm literally just going to go through them. And my right arrow should end up pointing up, which it does. So S shape, through. How many changes in direction do I have? Up, steady, up, down, up. That counts as 5. One more together, and then you're going to try this one on your own. So right here, I'm going to ZPP. I have 3, 0, and negative 1, 0. And it looks like I have one of each. So this is a double root because it's squared. That's my 3, 0. This is a triple root because it's cubed. That's my negative 1, 0. 2 plus 3, 5 x's. 5 changes in direction. Left arrow down, right arrow up. Okay, let's plot 3 and negative 1. And be careful again because I have double and triple. You should work with these slowly. It seems like I'm going quickly, but that's because I want the video to be shorter. So it says here that negative 1, 0 is my triple root. That's the first one that's going to show up. So I have to automatically, with my left arrow pointing down, draw an S shape through this, just like I did here. And then my 3, 0 is being bounced on. So when I come down, I'm not going to pass the x-axis, I'm going to bounce off of it. So up, steady, up, down, up counts as 5 changes in direction. If you have any questions, please post to Google Classroom. And remember, you should have copied all of this down for credit for today. You're going to do number 7 on your own. Plot here, and then upload to the posting. Enjoy the rest of your Monday. Bye.